Hello, everyone. This is Radha Dasari. I'm a technical education lead at Web3 Foundation. Today, I'm here to give you a high-level introduction of Polkadot and explore potential collaborations between the ecosystems. I'm very excited to be here. OK, so I'm going to do a trip of nostalgia here. So back in 2015, a lot of problems persisted in the blockchain ecosystems, right? So most of those blockchains were never designed to be interoperable. They couldn't scale well. For even simple use cases, they were having issues. There's not a lot of customization built into the technical stack. There was no concept of governance there, let alone like on-chain governance. And then making changes to these blockchain networks is a tough task. Then we had both of these white papers come in, like in 2016, almost at the same time. But both the ecosystems took different approaches to solving the same problems, right? So today, one thing I want to highlight from those white papers is, although the approaches were different, the underlying theme was the same thing. Both Cosmos and Polkadot believe that Web3 is not going to be, about blockchain maximalism. It's going to be multiple blockchains that are working together in cohesion. It's about openness and interoperability. So fast forward to today. So I took these snapshots yesterday night. Both Polkadot and Cosmos have 17 million blocks that are produced. OK, so I jumped ahead. So here is the first Genesis block that was there for Polkadot, right? So it was in 2019, and then Cosmos had its first block in 2019 as well. So on Polkadot, we have what's called Kusama, which is a canary network, which is a production-grade canary network. And fast forward to today, both these networks have like 17 million blocks, is what I was trying to say before. And yeah, in terms of the network itself, Polkadot as well as Cosmos, so we have several validators, several nodes that are running across the globe, path towards like the decentralization vision, right? So, OK, so let me introduce like Polkadot formally in a technical way. So Polkadot is a heterogeneous multi-chain. So it's a sharded network. It's a heterogeneous execution sharded network with all of these blockchains. So if you consider this as Polkadot, you have these individual blockchains which are running in parallel to it. So that's why they're called parachains. All of these parachains enjoy the pooled security given by Polkadot and the interoperability features. And just like Cosmos, we have these blockchains that are meant for a specific blockchain use case. So we believe that, along with you, that blockchains the use cases for blockchains can require a specific set of feature set that a generic blockchain framework can't give. OK, so before I dive deeper into the technical aspects of it, I want to give like a high-level overview that everyone in the audience can understand of how both of these networks work, right? So if you think of Cosmos, you're more like the world in general. So you have different countries. You can spin up a country with the Cosmos SDK and talk to other countries using IBC. You can form these zones. You can ask for security from powerful validator sets, which is all great. So it's an open way of like existing together in this world. Whereas Polkadot, it follows much more like the United States model, right? So you have these auctions for getting an opportunity to become a state, right? So parachains need to win an auction to get a lease for 2 years. So once they become a member state, they sort of enjoy the security given by all of the Polkadot validators. So the entire Polkadot security is going to secure every single member state. And in terms of like even consensus, the way it works is these member states, they don't have their own validators. They don't have their own military. So what they do is they sort of collect all the events that are happening in the state. They tell, this is my constitution. See, I'm a sovereign blockchain. I write my own rules. These are the events that have happened, and submit them to the federal, government there, and then Polkadot is going to evaluate both and then punish if there is some mismatch. So yeah, with that overview, this is the architecture. So like Cosmos, which is the Internet of Blockchains, Polkadot sees itself as a layer 0 blockchain as well. We have layer 1 blockchains, which can become parachains. And the opportunities are limitless there. So you can produce a blockchain that can do any sort of blockchain use case that is out there. And also the bridges, like if you were to implement a bridge on Polkadot, it has to be through this parachain interface. And unlike like Cosmos blockchains, so Polkadot parachains have what's called collators. So collators are the nodes that listen to the transactions that happen in the network, package that into a block, and send it to Polkadot validators. So the security assumptions here are that you just need like one honest collator, because that's one unique thing in the execution sharded environment like Polkadot. And the way I can show it to you live is it works this way. So you have these validator sets from the Polkadot validator set that are randomly assigned to an individual parachain. So you can see Asset Hub is a blockchain with 4 million blocks. Collectives is a blockchain with 2 million blocks. The collators of those blockchains are sending the blocks to Polkadot validators. They get shuffled. So the idea is that if you want to target an individual blockchain, you don't know which validators to attack. So the assumption is that you're going to have to attack more than 1/3 of the validators to sort of make damage to a single blockchain on Polkadot. Yeah, so a typical workflow looks like this. So collators are going to package a block. They send it to the relay chain validators. So they validate that block and then put a certificate in the relay chain. So they don't store that data. So it beats the purpose of execution sharding. They put a certificate in the relay chain saying this particular block is final. Cool. So let's look at how these validators are going to, sort of secure these networks, right? So Cosmos, uses delegated proof of staking. It's sort of a simplistic staking model, effective. It's currently you have like 180 validators securing the Cosmos hub. The target set you have set for that is like 300 validators. So right now Polkadot has 297 validators. We already have 1,000 validators on Kusama network. The idea is to expand it to 1,000 validators. And one thing I'm very thankful for both our ecosystems is that our nodes do not require supercomputers to run, right? So you as a normal person could rent out a cloud instance or like have like a bare metal at your home running these validators. And this is what decentralization is about. Anyone should be able to, with enough resources, should be able to do this. Okay, so a little bit of introduction to how nominated proof of staking works. So Polkadot takes it a little further, and then it sort of includes this sophisticated mechanism where you as a nominator are going to select 16 different validators. And the network is going to choose like where your stake goes to. And primarily, this is to ensure the network is secure overall, right? So we're talking about uniform security for all parachains. We don't want some validators with, let's say, 100,000 DOT backing them, and some validators with 10 million DOT backing them. So we want to avoid that divergence. So that's why the network kicks in, and then it sort of uniformly distributes the stake across all these validators. One of the key things it tries to minimize is the variance of the stake between the sets. So typically you have 1.8 million dot on the lowest stake validator and 2.2 million on the higher one. So just to give you an idea, so we go a little further in sort of ensuring it's tough to sort of attack these validator set. And in terms of consensus, we have Babe, which does block production. It guarantees liveness, so you'll not hear that Polkadot is going to shut down or it's stalling because Babe does its work. And then Grandpa is similar to the BFT consensus that Cosmos uses, right? So it runs as a separate gadget, and then it sort of finalizes everything. And you can see that both of our ecosystems are going towards making things even more effective. So we have Cosmos, which is looking for optimistic execution, which is going to make sure the execution happens separately or parallelly, and then you can finalize it immediately instead of pushing it to the last step. Polkadot, because consensus is very closely tied to the parachain's finality as well. So we have implemented what's called asynchronous backing, which is going to go live very soon. And this also increases the throughput of the parachains 8x, like you have more transactions and throughput with this particular optimization. Okay, so why both of our ecosystems have a stage in this whole blockchain ecosystem, right? So it's because anybody with a killer use case for blockchain, if they want to build a new blockchain, what do they do? What frameworks do they have to build it? So one, you have Cosmos SDK, and then we have Polkadot SDK with like Substrate as a part of it. Both these software development kits take care of all these three problems. One is, it's a lot of overhead to write blockchain code from scratch. It's a humongous task. You require a lot of resources. And then you have the problem of isolation. Okay, so you created an island in this world. How are you going to interface with everybody else in the world, right? So Cosmos does like a fantastic job with IBC. And then we have the issue of security. So I'm this island. I'm starting this new use case. How do I get my security? First of all, like the blockchain ecosystems, they work in adversarial environment. Everybody wants to take advantage of you. So how do you ensure that your protocol runs as expected? So both Polkadot and Cosmos have designs and solutions to address all these challenges, which is great. And in terms of like Polkadot SDK, I just want to, for the developers in the room, I want to give you the core technologies that make it. It's Rust programming language, which is very type safe, very good optimizations. You can build like really, really good optimized applications with Rust. And then the core part of like the whole SDK is that the output is going to be in WebAssembly. So this WASM, which WASM has taken the main stage across like different technology stacks of blockchains. So we have these two as the key things in the SDK. And we also have what's called Frame. So Frame is a bunch of modules that you can plug and play in your blockchain network. And the way it works is, okay, so I want a blockchain with staking, governance, and some other feature like a DEX. I'm just going to bring all those palettes in, compile my blockchain node, and then start a blockchain network. Yeah, so together with WebAssembly, and then we have networking stack of lib peer-to-peer protocol developed by IPFS people, and the blockchain's core functionality in this WASM blob, we have a node that is running. And the key thing here I want to highlight is that it is safe to execute. So WASM runs in its own sandbox. It doesn't have the ability to do more to the host. So it does what it is supposed to. It's easy to share. Polkadot WASM code, it's about 1 MB in size. So you just like share it with all the nodes easily. And it's sort of generic. You not only can have blockchain runtimes, you can have like smart contract execution, you can have chain extensions. It can go further and further. And WASM is not new to Cosmos ecosystem. So you have CosmWasm, which focuses mainly on smart contracts. But in Polkadot, we do it, we use it for making it a meta protocol. So it's not just the smart contracts that we run. We sort of run everything related to the blockchain. The brains of the blockchain is in WASM. So typically, what happens is a Polkadot validator node, they don't have to run multiple binaries when they're like validating different chains in Polkadot ecosystem, right? So what they do is they think of it as a gaming console. So I'm going to use Polkadot WASM and then use that to validate these different parachains. So you have a new blockchain. OK, just give me the WASM code. I'm going to plug it in, and then I'm sort of going to validate that. And this gives rise to efficient governance as well, which we have rolled out like this, the second version of governance, which is called OpenGov. We have like multiple tracks with multiple origins with different privileges. People can vote on it, and then we also have what's called Polkadot Technical Fellowship. So those are the developers, core developers of Polkadot protocol, who are assisting, network critical updates to go through that whitelist origin. And the whole WASM-based like governance lets you have what's called a forkless upgrade. So typically, blockchains in general, they'll have to fork if they don't update the binaries. So in Polkadot, because the WASM blob is going to be part of the blockchain till it gets like executed, the moment the upgrade happens, the next block is going to be produced with the updated WASM code. So we have this architecture which makes it very seamless to upgrade the blockchains as well. Yeah, let's talk about interoperability. Clearly, like Cosmos is the big guy in this room of blockchain interoperability. So IBC is like very flexible, very easy to incorporate, great developer experience in terms of doing stuff, right? So the key thing here is Internet of Blockchains. Of course, it needs like interoperability. And trust the chains, not a bridge. This is very important, given in the last year, there has been millions of dollars that were hacked away in inefficient bridges, right? So it's great that Cosmos has this emphasis and then is developing this protocol day to day to be useful. So similar to that, like in Polkadot, we took a different direction. So we have what's called XCM, which is like a programming language for chains to communicate with each other. There have been efforts by somebody in Cosmos to use this in the ecosystem as well, and then vice versa. Like there have been parachains that have integrated IBC into like Polkadot ecosystem. Anyway, so the idea is similar, like what IBC is trying to achieve, Polkadot is trying to achieve it with XCM. So XCM comes with this XCM executor. Earlier, I told you it's easy to upgrade the blockchains. So what happens when a completely new function is added or something about the function has changed? So the XCM executor is going to take care of that. And then you have the ability to configure that executor. XCM is live. All the chains within Polkadot are able to communicate with each other. We are still working on the trustless bridge with Ethereum, so the test network is sort of live. We're hoping the production network goes live soon as well. It's great that Ethereum is already bridged to Cosmos. And yeah, so I mentioned to you earlier, there have been projects that were bridging both Cosmos and Polkadot. So we have like Composable that has showed this proof of concept working through the Centauri project. And I'd just like to highlight, so what's the reason all of us are here? We're trying to build something useful and important to the world, groundbreaking technology. So both our ecosystems are trying to make it possible that you could do more than cryptocurrency, you could do more than sharing JPEG images on blockchains. You're trying to address like real problems with like blockchain use case, right? So I would say like both the ecosystems are moving in the right direction, trying to provide the technology to do so. We are like very flexible, customizable, and interoperable. And I would sort of end this talk by saying, there are potential avenues where we can like sort of collaborate together. Polkadot provides this type-safe Rust WASM environment, which is secure. From day one, you just plug in as a parachain, and then you get all of this. And you get access to every single blockchain in Polkadot ecosystem if you do that. And then vice versa. Like Cosmos, which is like the world model that I showed, it's of great interest for Polkadot developers as well. To enable the collaboration better, I would see this core time model being like very useful. So Polkadot is removing that entry barrier of becoming a parachain. You could actually get the core time of the validators of Polkadot more easily. So if you are interested, check this out. This update is going to roll out very soon, this year, hopefully. And if you have further questions about Polkadot ecosystem, grants, or anything, I'll hang out here. Thank you very much for giving this stage to speak. Thank you.